All right, everybody. Sorry about the fuzziness here. We're going to start with myristic acid in blue and myristic acid. Myristic. Page what, Ali? 1955 of the 2009 Aldrich. Okay, and I need the formula weight as one item. That'll get you a point. So what's the formula weight they listed there? 228.37?
Yeah.
And what are the units? They don't have them there, but we're supposed to know this from inorganic chemistry, 1, 2, 3, 4, whatever. Formula weight, periodic table. What are the units? Couldn't pass the course without them. Grams per mole. Now, you don't know this yet, but along the right side of that whole entry for myristic acid are prices. They don't have dollar signs. They'll have an amount of chemical and how many dollars it takes to buy it. I need the cheapest price for myristic acid. And remember, in general, in life, when you buy in bulk, you generally get a better rate. So you will not be buying a small amount, you'll be buying a large amount. So did you find $73.10 for 500 grams? $73.10 for 500 grams. You must use the most economical price you can find. And that is the only two pieces of information you need for myristic acid. We had students hunting around for the alcohol's name, and I believe the only one that had success was 2-methyl-1-propanol. Maybe going off the screen. We are off the screen. This is our first time trying this setup here. What page was that on? 1908, same catalog. What was the formula weight for that one? That sounds right. And what's the best price? There's a lot of entries there, isn't there? So if you're on page 1908, the one we found this morning was, you could buy 20 liters of the stuff for how much? $80. We did a little better this morning. No, we did a lot worse. You got it for 80? You did a lot better than us. For 20 liters. Yeah, that's a lot better than what you said earlier, right? Because you'd have to multiply that price that you found earlier by 10 to compare to 20 liters. So it's 348 for 20 liters. Now, you're buying this one by volume. You need one more data point. When you're buying a volume, you better know the density as well. It's on page 1908, right where you found the formula weight. The density should be nearby. 803 grams per milliliter. And the paratoluene sulfonic acid I need its formula weight and its page number 2545. And what's its formula weight? 190.22 grams per mole. And what's its cheapest price? There's a lot of entries there too, I know. This morning we found you could buy 15 kilos, $223.50. Now, I hope I don't lose anybody here. I'm going straight to 15,000 grams. That's 15 kilos, isn't it? Can barely see it. There we go. For each chemical, I'm going to need dollars per mole. Right now, you got dollars per grams, dollars per liter, dollars per gram. We need to convert those to dollars per mole. I love conversions. They made me fall in love with chemistry. I got something on this page that can get rid of grams and give me moles. It's right above. There are 228.37 grams of myristic acid in every mole. When I'm done, please do the math for me now. 73, 500. Well, that's a little less than a half times 73. We're in the 30s. In the 30s for dollars per mole, but I need an exact number right now. Two students. 388 dollars per mole. The next one, I've got to get rid of liters and make it milliliters. So times milliliters and liters. Which one's the bigger one, the milliliter or the liter? Liters are bigger. It gets a 1. How many little millis are in there? 1,000. So now you're at milliliters. Got to get rid of that and get to grams. Hey, now you know why you needed the density. There's 0.803 grams for every 1 milliliter. Now I got to get rid of grams and get moles. Oops. I didn't do a cancel, did I? No, you yeah. Thank you. Yeah, that's the nice. That's the interruption I want to have. Yeah, I'm gonna have liters squared on the bottom and dollars times mill. This is like a total. I don't have words without swearing. You know what I'm going with, right? So that's 1 liter for every 1,000 milliliters. Yeah, my bad. 1 liter for every 1,000 milliliters, and that means I gotta get milliliters on the top of this one, right? I know, it's a disaster. Pretend it's not even there. We're canceling liters done. Milliliters got to cancel here. Milliliters, grams on the bottom. 1 milliliter for how many grams? Yes, sir. And we're not at moles, dollars per mole yet. I think we recovered just in time. Grams canceling, leaving with dollars per mole. And that's the formula weight, 74.12. I need a couple students to corroborate that. 0.3, 0.8, it's here, half over 20. Oh, this is, I don't even want to try. I'm not even going to try to ballpark it. Somebody work it out for me. I think it's a lot cheaper than the first one. Correct. If you can't read that, it says $1.6061 per mole. Once again, you'll have a nice clear version when we're done. And dollars per mole on the last one. Times, we're buying it by grams already. Got to get rid of grams and make it dollars per mole. There are 190.22 grams for every mole. So 190, 15,000. All right. Not even gonna try. More than 2, but less than 3, isn't it? 2.8. This morning we got 2.8343. Is that correct? Trying to keep some extra sig figs. So we've got $3 per mole here that we need. These two are critical to compare. Those are the two reactants that give us our product. Which one is a lot cheaper? These are the two numbers. Yeah. So which one you not mind wasting and using as the excess chemical? Same answer, 2-methyl-1-propanol. This is excess. This is limiting. Please don't ever make the catalyst either the excess or the limiting reactant. Reactant because it's not a reactant at all. The catalyst. That's good. So we got some work to do. One, we got to figure out what our ester looks like. We never did that. So I do need some students opened up to page 1908. And some different students opened up to page 1955. And we're going to draw our ester. Tell me what they said for myristic acid structure in terms of CH3 bloody bloody die. There's something written there. Page 1955. CH3, CH2 in parentheses taken 12 times, CO2H. Now, please, you have to know that an ester has all of the carboxylic acid except for the OH. So copy this as a stick figure in the box up to the carbonyl. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Draw the carbonyl. Now, I shouldn't have to look it up, 2-methyl-1-propanol, but I bet they do give a condensed structure there, don't they? Parentheses, maybe? Somebody has page 1908 open? Or maybe they don't give any information at all. CH3 taken twice. CH2OH. You do need to know that the O of this ends up attached to the carbonyl. We have to know that. That's organic chemistry 1. Ester has the O, which is attached to a CH2, which is attached to a CH with 2 methyls. So you will be drawing the stick figure. And let's do some magic to get the formula weight, because I'm telling you now, I'm not going to tell you again, you will not be able to research your ester. It won't be in the book. You do not need to research your ester. You have everything you need here. You have enough information to calculate its formula weight, and I gave you its density in the question. So the formula weight, this is not magic, 228.37 plus 74.12 minus, when you made this molecule, you lost 1 water. On the midterm, it will also be 1 water. No magical diesters or anything. It's a straightforward 1 alcohol, 1 carboxylic acid gives 1 ester. And I need an answer for that. 228.37 plus 74.12. That's this plus this minus water. And what'd you get? I need one person to verify 284.47 grams per mole. Excellent. Good. Because now you can convert your theoretical yield to moles. If you're going to talk chemistry, you always have to talk moles. So here's your theoretical yield. I'm going to multiply it by the density. I can't see it. It's on the top of the page. 1.212. I don't know if you, yeah, you can see that. Times 1.212 grams per milliliter times 1 mole for every 284.47 grams. And I'm going to get a theoretical yield, and I'm going to make sure it's boxed out. One 1.6376523 centimeters cubed times 1.212 grams per milliliter, the density given at the top of the page, times 1 mole for every 284.47 grams. And I think we did that right this morning. And I don't know where our answer was though. Oh, there it was. No, they didn't use the right volume this morning, so I need you. It's going to be big. And we're going to have to edit the amount of money Mr. Branson's offering us to. It's okay. What'd you get? This big number times that number divided by 284.47. Did somebody else also get that? That's moles. 697730.82. Did somebody else get that? I like it. So that's your theoretical yield. You have to plan to make that amount of ester. You have to use the conditions given in the question. I'm going to figure out dollar amounts for each chemical right now, starting with myristate. I'm just going to use the short forms now. Myristate. You're going to take 697730.82 moles ester times the stoichiometry, which I promised you is going to be 1-to-1. 1 mole myristate for every 1 mole ester times, this is not magic here, sorry, everything's moving, $33.388 per mole. 33.3. I hope I remembered that. Somebody verified so I don't have to move the screen. $88 for every mole. And I need a big answer in millions of dollars. So right now you would tell Mr. Branson to take a hike. But we based that offer on this morning's calculations, which were in error. Okay. So 697,000 times 10 is 6 million times 30 is 18 million. So 20 million. I need a number. I'm just talking. 2329 36. And we're talking dollars, so let's go nearest dollar, and that's 6 days 6. So 37, correct? Yeah, we're like the IRS now. I only want the nearest dollar. So yeah, 23 million just for that one chemical. This morning they forgot to square their radius. Pretty sure. I'm going to call it isobutanol just because it's a shorter name. No, I can't write either. We need to use, don't comment until I finish writing here, 697730.82 mole ester times 1 mole alcohol for 1 mole ester times 2.75. That is not made up. That's one of your conditions. Times dollars per mole was 1.6061. Is that correct? So why did I multiply by 2.75? Please look at the question and see where I got that from. Condition 2, correct? Use a 2.75 fold excess of the cheaper one. We have to determine the alcohol's cheaper, right? And you're going to spend a lot less than $23 million for that because it's real cheap. 20 times cheaper, pretty much. 20 times cheaper, but you're using 2.7 times more. 2.75. What'd you get, Allie? Oh. Okay. Can't trust you. I don't have numbers anymore. So basically, that big number times 2.75 times 1.6061. Does the 0 stay 0? Okay. And that one is just 3 million. Good. And PTSOH. We'll do that in dark blue. PTSOH. 697730.82 mole ester. Catalyst, and you're told you're going to use 1.5 mole cat for 100 mole ester. Where did I get that from? Condition 3, use a 1.5 mole percent. You got to convert the percent to a fraction, 1.5 over 100. And then multiply by the price times, and we're talking 2.8343 dollars per mole. And give me a number. It's gonna be cheap. I can give a ballpark. 200 was 10 times less than the previous one. So the ballpark is 300,000. But we don't use ballparks. Trying to make money. So it's a 4. So 29,664. And can you add up the 3 green numbers here for me, even if you can't see them? 26 million. So it's not going to go past 26 million. 26 million. Just add this to this to this. You got to buy all 3 chemicals. Maybe 26.3. What's after that? You can't read the number. Is anybody trying it? Do I need to do it? 26,364. 407. What's after that? 320. 220. 220. So I'll read it slowly so you can copy it. 26,407,220. And I have to change the question because he offered you $200,000. You say, take a hike. I am not going to lose money to make you this Esther. So we're going to change his offer to 30 million. So we're editing the question. $200,000 is now 30 million, which is better because on the midterm it is millions. The offer is in millions. I'm glad we caught this mistake. So our job now is to calculate. This will be a % profit because he's offering you more than you're spending. When you are offered more than you're spending, you're making a profit. If you're offered less than you're spending, you're saying no, and that's a deficit. And I'm gonna carry this on. I know you can't see what I just did. Remember, 30 million, right? Okay. I need the whole bottom. And I'm just taking this total. Your % profit equals what he's offering you minus what you're spending, 26,407, 220 over what he's offering. And of course, I ran out of room and I need to multiply by 100 because it's a %. Can I put the 100 in front? That doesn't change it, right? So we're talking a difference of for 3,600,000 over 3 million. It's more than a 10% profit. I need an answer though. Yes, I accept. That's part of your, you get a point for saying that. If he's offering you more than you're spending, you say yes. If he's offering less than you're spending, you say no. That's that simple. And what'd you get? 11.98% profit. End of problem. End of segment of video.